Okay, hi everybody. I know we said that I'd be moving on and we'd start looking at threats to the oceans, but I've got one more thing to talk about before we do that. So we will look at that later on in the week. But since we learned about types of water, various types like blue water, gray water, black water, that sort of stuff, um, I wanted to talk a little bit about water treatment. So what do we do in order to treat the water before we return it to our waterways? In our case, to the Thames River. Um, yeah, so I've got a little presentation here that goes over the water treatment process and some questions that I'd like you guys to look up and answer that deal somewhat generally with water treatment and then specifically with water treatment in our context here in London, Ontario. So I won't click on it, but I'll let you guys click on that link to watch a video called Flush to Finish. And it is not from London, Ontario, but it does illustrate with a wastewater treatment plant that's very similar to the larger plants we have here, like the one that we have at Greenway Park. So, Greenway Sewage Treatment Facility is very similar to the tour that they give you in that video. And it looks at the stages of water treatment from filtering out solids, suspended solids, things like that. Um, right through to treating other organics, and then to do some sort of final UV treatment before water is returned to our waterways. So I'll let you click on that. What I'd like you to highlight as you watch are the different stages of water treatment, and I want you to think about possible problems that could occur at each of those stages in that process. Okay, so after you've watched that, let's move on. So if you recall from the presentation I gave last week, I talked about the possible fates of water, where water goes, and we differentiated between storm water, so that's water that falls as rain or snow and then melts, and actual sewage water, so actual water that needs to be treated in a treatment facility before it is returned to natural water courses. And when we're looking at these wastewater treatment plants, we are looking at that second type. So we're looking at water that, you know, leaves your toilet when you flush through the pipes, through the sewage system, and eventually makes its way to one of our sewage treatment facilities. So, what do we have to take out of that water before we can safely return it to, in our case, again, to the Thames River? So, the first thing we need to get rid of, and it's fairly straightforward to do so, are suspended solids. I see in my presentation there it says suspended soils. That should read solids. And other objects. And you might say, well, what do other objects consist of? If you watch the video, you'll see that all sorts of strange things make it into the sewage system that have to be removed, from things like diapers and such to larger items like construction material. Somehow makes its way there, that have to be filtered out, taken out, before we can start treatments for other things, such as uh, biodegradable organics. So, organic material that needs to be broken down, and it's broken down by living organisms. So, microbes are introduced into the process, and those microbes will actively eat away at organic material that's in our wastewater, and it will consume a very large percentage of that organic waste before a final treatment is done to kill organics that we don't want, microbes that we don't want before the water is returned to the river. And that's measured by something called biological oxygen demand. And what that looks at is the amount of oxygen that's being consumed by aerobic microbes. So those are microbes that do their work in an oxygen environment. They consume oxygen in order to eat that organic material. So in order to break down that organic material, these microbes, these bacteria, they need to consume oxygen in the process. So the measure of biological oxygen demand, or BOD, the higher the measure of BOD, that means the higher is the rate at which these organisms are actively breaking down that organic material. So high BOD means there's a lot of activity by those microbes to break down that organic material. If there was a low BOD, it means there isn't very much organic material to be broken down. Pathogenic bacteria. So those are harmful bacteria, things like E. coli. We will later on in the week look at a case study that, well, you might not have heard of. It might be a little before your time now, but in Walkerton, Ontario, in southwestern Ontario, not that far away from London, there was a tragedy some years ago where the water supply, they were on groundwater, so well water, the water supply got tainted by E. coli bacteria in a really a systematic breakdown from the actual municipality. So the people that are supposed to be testing and ensuring the safe water supply, there were multiple breakdowns, and E. coli got into the water system, poisoned it, and a large percentage of the population got sick, with several people dying, so actually losing their life because of that. And it actually caused a lot of change in terms of policy in Ontario in terms of how water is managed. And lastly, nutrients. So we want to make sure that there aren't nutrients like phosphorus um, in the water. So things that are from detergents, excess nitrogen, we don't want in the water, because if that makes its way out, that will lead to eutrophication, which are algal blooms that occur. In our case, it would be in the Thames River, which makes its way to Lake St. Clair and makes its way into Lake Erie. And if you know anything about Lake Erie, it's extremely susceptible to these algal blooms, and they can choke out, they can consume a lot of oxygen, causing mass kill offs of fish and other aquatic creatures. So those nutrients also have to be dealt with. Okay, so I'm going to go through each of those and talk about how what wastewater treatment plants, wastewater treatment systems deal with them. The first are those suspended solids. So it's pretty straightforward, actually, to deal with those. What they'll do is they will, particularly those ones that float or settle, they will filter out. So they'll pass it through, like a grate, and anything that is of a certain size won't be allowed to fit through that grate, and then can be filtered out from the system before other measures have to be taken with the organic material that's left, or those pathogenic bacteria, or other nutrients that we don't want. So here we go. Here's those biodegradable organics as measured by BOD. So in this case, it seems a bit counterintuitive, but in a wastewater treatment plant, you actually want to introduce bacteria into the system, in this case, in order to break down that organic material that is present when all the people of London, Ontario flush their toilets. So bacteria in this instance is introduced into the system so that it's able to break down in the presence of oxygen, is able to break down that organic material. If you didn't have this, so what would happen if you released that straight out, which does occur every now and then? Remember, we talked about those bypass events. It can lead to just zones where oxygen becomes depleted, because if it does make its way out into our water courses, other microbes will start to eat it, to break it down. And when they do that, of course, they're consuming oxygen, and if there's enough stuff for those microbes to eat, it can lead to a depletion of oxygen so serious that it leads to mass kill offs of aquatic organisms. And you can sometimes tell this. There'll be, a foul odor and discoloration of the water, which could be because of the release of these biodegradable organics, and uh, the subsequent use of those biodegradable organics by the microbes. Pathogenic bacteria. So a pathogen is a harmful bacteria, is something harmful And in this case, it's not, E. coli is just one example, and it's um, particularly particularly relevant because, of course, you could get E. coli from several sources, feces being one, and it's extraordinarily harmful if it gets into the water supply. And if you look at the map from last week that I showed you with, or maybe even 2 weeks ago, where we looked at the Thames River watershed, when you guys flush your toilets, that water makes its way into the Thames River, which will flow west all the way to Lake St. Clair. And from Lake St. Clair, that water makes its way into Lake Erie, which is one of the two main sources of water for London, Ontario. So, yes, the water that you flush and eventually makes its way through our sewage system and through our wastewater treatment plants, it eventually makes its way into Lake Erie, which is a spot where we get our drinking water from. So it's extraordinarily important, of course, that we do everything we can to ensure that that water is safe. So it's it would be uh, it would be a tragedy regardless to have raw sewage dumped straight into the river, but even more so because eventually that water makes its way back to us as water that we use to drink. And nutrients that we talked about. So it's mostly nitrogen and phosphorus that we're looking at, and the sources could be detergents. So a lot of them you'll see now that say phosphate free, if you're looking at laundry detergent or something like that. And the reason being that it was recognized quite a while ago that it was a major cause of these algal blooms. So in a process called eutrophication, those those nutrients, phosphorus, nitrogen, are often limiting, meaning that algae can grow and divide to a certain extent, but they need nitrogen or phosphorus, or in some cases even iron. That's the limiting factor in the environment. So it limits their growth. But when we start pumping it in, either through detergents or through fertilizers, agriculture is now a major culprit. That's when you get out of control algal blooms. And that could be bad for the local aquatic life, as I say, because it can deplete the area of oxygen, causing die-offs of aquatic life. But it also can 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 cause the increase of toxic algae, which actually release toxins into the water. And again, if that water is a source of drinking water, which for us it is, that's extraordinarily bad. Um, and to make matters worse, when you have these toxins that are released, it's not a case where, like if it were just bacteria, you could boil the water. And you've probably heard of boil water advisories before, where the government or the local authorities suggest that before you drink the water or use it to cook, you should boil that water to kill any sort of living things, any bacteria that's in there. If you do this with the toxins that are released from certain cyanobacteria or algae, what happens is you just end up concentrating those toxins. Boiling doesn't kill them. All boiling does is it takes the toxins that are already there and concentrates them, because you're boiling off the water and leaving the toxins. So particularly important that we focus on eliminating those nutrients, nitrogen and phosphorus, that can cause those harmful algal blooms. Okay, so I won't go over this in too great detail because you saw it in the video, but the steps to water treatment are usually come in three phases. So there's a primary treatment, which looks at removal of those bigger items, the actual physical separation, or passing them through a grate or a strainer type setup. A secondary treatment that involves the introduction of organics to break down other organics that we don't want, and then a tertiary treatment, which should kill any of the remaining nutrients and microbes that we do not want to put back into the system. So that primary treatment, it's mainly mechanical. Mechanical meaning that we're not hitting it with a bunch of chemicals or that kind of thing. As I said, we're just passing it through large screens so that anything bigger than the size of the holes in the screen gets filtered out. So that's kind of step one. It catches the big stuff, basically. I should also mention that in this process, so we can screen out that big stuff, and then what we do is, you might have seen, if you've ever gone near one of these sewage treatment plants, they have big kind of holding tanks. And these holding tanks, what they'll do is when the water so it goes through the screen or filter, big stuff gets sorted out. And in these big holding tanks, they allow the water to sit so that the sediment can come out, and just by gravity, it will go to the bottom. And what they do is they'll have a big, uh, almost looks like a fan blade that will scoop that sediment that's gone to the bottom and get that out of there. So in that primary treatment, they screen it, big stuff gets filtered out, sediment is allowed to settle to the bottom, and it's removed in that first stage. The secondary treatment, that's, as I said, that's the reintroduction or the introduction of living things, of microorganisms into that water that still contains organic waste from when you flush the toilet, and those biological agents act to break down that organic material. And sorry, let me move this out of the way. About 85% of those biodegradable organics can be removed with this introduction of microbes, of bacteria that will actively eat that biodegradable organic material. So a large percentage are removed by the time that secondary treatment is done. And then we get to tertiary treatment. And this involves more advanced treatment. It's not just a simple mechanical filter or an introduction of bacteria that will help break down some of those organic solids. Now we're looking at things. Now we're looking at the introduction of chemicals. So you're going to chlorinate now, as that will kill a lot of the remaining microorganisms that we don't want to leave the sewage treatment plant and enter our natural waterways. It can also involve, so as I said, chlorine. The plants in London, the major pollution plants, will all chlorinate the water, and they also will now disinfect through ultraviolet. So the water, before it enters back in to a drain and then eventually into the river, will undergo a UV, ultraviolet radiation treatment, that again kills most of the microorganisms that are left. So any microorganisms we don't want will be killed by that ultraviolet radiation or chlorine or a combination of both. So what I'd like you guys to do now is answer some questions that I have, some of which you might be able to get the answers from either this presentation or from the video that you watched. Some of it you're going to have to do a little bit of research for. So I've put this on a document on the classroom, and I'd like you to do this research to answer those questions. And I've helped you out a little bit on the document. You'll notice I've given you some links. So for the first few questions, you're just going to have to look those up, including where the sewage treatment plants are located in London, Ontario. You can either, when you answer that one, you can just give me the locations of them, or if you want, if you can find them on Google Maps or something like that, you can just take a screenshot of their locations on Google Maps to show where those plants are located. The one where you have to do a little bit of work in terms of gathering information, gathering data, is question 5. So looking at sewage bypass events. And those bypass events, remember, are times when the treatment facilities get overwhelmed. So when we have intense rainfall for a period of time, and the situation where we have combined sewers like we still have in several old parts of the city, where the storm water that goes down the drains on your street are combined with the water that comes from your household. And again, when it's raining too much, people don't stop flushing their toilet when it rains. So that combined system sends a flood of water to treatment facilities, they can't manage it. So remember, they have no way to differentiate the storm water from the sewage water. And if it's going to overwhelm the facility, they have to open up the valve and release some of that water, a portion of that water, right into the river, untreated. So obviously, if you're London, you want to do your best to minimize and hopefully eliminate sewage bypasses. In an ideal world, we would have zero sewage bypass events per year. And as we continue to eliminate combined sewers, we're working on it, but it's expensive, time consuming, and of course, you have to rip up all the roadways to get to those pipes. So it's inconvenient for a lot of people. So I've given links for question 5 where you will look at sewage bypass events, and you'll also look at um, rainfall and see if we can find a correlation or a link between the two. So you don't see the link right here on the screen, but there is a link on the actual document itself. Okay. If you have any questions, as always, just ask them in the comments section under this assignment, or send me an email. And yeah, have a good day.